Alright, in this lesson we are going to go over the quadratic formula, which is one of the most important lessons that you're going to need to understand and write notes on, because there's different things that you'll need to know when using the quadratic formula. But the quadratic formula is made for one reason and one reason only, and that's to find roots for a quadratic equation, for a parabola. Alright, that's its only purpose, is to find the roots, wherever that parabola hits or crosses the x-axis. So step number one, what we're going to do is we are going to write down carefully what the quadratic formula is. So quadratic formula will be used when your equation, when your quadratic equation is in standard form. You have to get your equation into what's called standard form. So this right here, this is considered to be standard. Alright? Where you can identify the a value, the b value, and the c value. So that's step number one. You got to get everything to standard form. So all I'm going to do to get our little equation into standard form is I'm going to take this, I'm just going to move it across the equal sign, which will make it a positive 6x, okay? That's a little bit, it's not very traditional. Let's do the traditional way where you add 6x to one side of the equal sign and add an additive inverse of 0. And then you will add 6x to the other side. And when you list it out, you're left with 3x squared plus 6x plus a 1, and that's all equal to a 0. And then you can easily identify the a value as a 3, the b value as a 6, and the c value as a 1. Now, if you would have moved this over to the other side, then the only thing that would have been different is this would have been a negative 3, this would have been a negative 6, x, and that'd be a negative 1. And then you'd have to change all your values to negative, negative, and negative. So we're just going to keep this nice and neat and just keep it positive, all right, just to start out. And now you need to write this down in your journal because you're going to be using it over and over again. And this is the quadratic formula. So go ahead and title it in your journal. This is the quadratic formula. All right. And the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to put x equals, all right? I'm trying to make a better b than that. Negative b. One more time. Let's make it nice. There we go, negative b. So if you would, that right there is the quadratic formula. X being your root, whatever the x value is, will be negative b plus or minus the square root of b squared minus 4ac over 2a. Now the number one and most important thing that we're going to be working with right here is this value known as b squared minus 4ac. And that has a specific name. That is known as the discriminant. Okay? That's known as the discriminant. Your discriminant is known as b squared minus 4ac. It's called a number. The number is known as the discriminant. It could be a positive, it could be a negative. Now there are different things that the discriminant can be. If it equals 0, if b squared minus 4ac equals 0, that means you have a situation where you have what's called one real solution. Okay? So I'm going to type in an equation where you'd have one real solution. So here we go. I'm just going to go ahead and type it in. Alright, here's a situation where we have one solution and only one solution. X squared, say plus 6x plus 9. There we go. That's it. That's a situation where if you were to plug a, b, and c in, it would equal a 0. You have one solution. Alright, that's an example for one solution. Now, you could also have a situation where you have b squared minus 4ac is greater than 0. Alright, it's greater than 0. But if this, right here, b squared minus 4ac, happens to be a number that's considered to be a perfect square, and you're like, what are perfect squares? I'm going to put a set of perfect squares, okay? Here's your perfect squares. You got 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 25, comma, dot, 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 keeps going forever. Those are perfect squares. If they are perfect squares and it's greater than 0, that means you have two what's known as rational solutions. A rational solution is not considered, basically it can be put into the form of a fraction, known as a ratio. Two rational solutions. Okay, so here's an example of a situation where b squared minus 4ac would end up being a perfect square. You'd have two perfectly nice, neat, rational solutions. I'm going to put, let's see, here we go. There we go. -5, those are two rational solutions. So this b squared minus 4ac would end up being a perfect square, and you'd have two solutions that are considered to be rational numbers, -5 and 4, because both those can be put into the form of a fraction. Now, here's another scenario. You could have b squared minus 4ac is greater than 0, but if this number is considered not a perfect square, if it's not a perfect square, then you're going to have what's called two irrational solutions. Okay, two irrational solutions. Now, what does irrational mean? Well, irrational means they're not perfect squares. I'm just going to put see how this works. That's probably rational. Let's put 19. There we go. I'm not sure if these would end up being irrational. Let's say here, put 20. There we go. Those are rational. There we go. Those look like they might be irrational. Something that you can't. Those look like it might be in the form of a fraction. We'll get to an example where they're going to be irrational. We'll probably have some examples, and I'll tell you about what irrational numbers are. Irrational numbers are numbers that you cannot put in the form of a fraction, like these radicals. Okay, where you get solutions where you have a radical in it. Those are two irrational numbers. All right, and now last but not least, we could have a situation where b squared minus 4ac could be less than 0. Could be less than 0. So if it's less than 0, that means you're going to have what's called two complex solutions, because they're not going to be in the real number system. All right. For our case, we're going to put no real solution. So if it's negative, if this number ends up becoming negative, so right here, this right here is any negative number. If it's any negative number, you're going to have what's called no real solutions. You would have two complex solutions, but that's Algebra 2, not necessarily Algebra 1. So your two possible answers, all right, for the discriminant, all right, are going to either be one real solution, two real solutions, or the last answer would be no real solutions. I know that's a lot to take in. So right now, what we're going to do is we are going to find the discriminant first. We are going to take, right here, we're going to take b, which is 6, squared, minus 4 times my a value times my c value, which is a 3, and a 6, and right here we are going to take b squared minus 4 ac, which means 4 times a times c, and we're going to find the value of our discriminant. So 6 squared is 36 minus, we have 4 times 3, which is 12. All right, and then 12 times, oh, my c value is 1, not 6. My bad. There we go. I was messed up there. Always important when you're plugging in numbers to plug in the right numbers. All right, so 4 times 3 is 12, so we have 36 minus 12. Our discriminant is the number 24. What does that mean? That means the number I'm going to plug in right here into that radical is the number 24. That is not a perfect square, so I'm going to end up having what's called two irrational numbers because that was not a perfect square. So here we go. Let's go ahead and write everything down nice and neat. So we have negative b. So if our b value is 6, we're going to write negative 6 plus or minus the square root of 24. If you're wondering where I got the 24, that's the value of my discriminant. Whatever the number is in here, that is called the discriminant. All over 2 times my a value, and my a value is 6. So here we go. We have a couple of answers. Now you'll notice none of our answer choices have -6 plus or minus the square root of 24 over 6. None of them look like that because we actually have to simplify this. You're like, what in the world do we have to simplify? We have to simplify the square root of 24. How do you do that? You've got to break it down into its factors. Well, what are the factors of 24? 4 and 6. What does 4 break down to? 2 and 2. What does 6 break down to? 2 and 3. But square roots, even though you can't see it, there's a little 2 right there. It's looking for what's called groups of 2. We got a group of 2 right there. So we can actually pull a 2 out of the radical. Well, what's still left inside the radical? 2 times 3, which is 6. All right. Here's what I want you to understand. These are exactly the same approximate value. If I say, what is the square root of 24, and I just type in 2 radical 6, I want you to see they are exactly the same approximate value. This is just considered to be simplified. This is considered to be unsimplified. And we have to simplify things. So how do I simplify my final answer? I rewrite it. All right. Now, square root of 24 becomes 2 radical 6. What is divisible into a 6, a 2, and a 6? There's only one number that's divisible into all of those, and that number is 2. So I'm going to take half of that, put a 3, take half of that, put a 1, take half of that, put a 3. So here's my final answer. -3 plus or minus radical 6 all over a 3. Now, they could also, if they wanted to, they could write it like this. They could write it as 3 plus or minus radical 6 all over a -3. So the negative could be in the numerator or the denominator. I think this is the best answer, but you could find it either in the numerator or the denominator. So let's see which one we're going to choose. All right. Looks like they put it in the denominator. So we're going to choose answer choice C. All right. Now this one we're going to go a little bit faster. I'm not going to talk about the discriminant for a long time. This will go a lot faster. So the first one was just for you to take notes on what the discriminant is. This one will go a heck of a lot faster. All right, here we go. First thing we're going to do is we're going to write everything down. And then we're going to set everything equal to 0. Okay, we're going to set everything equal to 0. So the first thing I'm going to do is I'm going to add 6x to this side, and I'm going to add 6x to this side. So here's what we have. We have -7 x squared plus 7x plus 9 all equals 0. Now that puts us in the form that we can use, which is standard form. All right, and we can have our a value. Our a value here is going to be -7. Our b value here is going to be 7, and our c value right here is going to be 9. Going to write down the quadratic formula. -b plus or minus the square root of our discriminant, which is b squared minus 4ac all over 2a. Put x equals. All right, first thing we're going to do is we're going to find the value of our discriminant, which is b squared minus 4ac. Always use parentheses because they matter. We're going to plug in a 7 for our b value. We're going to plug in a -7 for our a value, and plug in a 9 right here for our c value. So we're going to put 49. Now a negative times a negative is a positive, so we're going to put a plus. I'm going to put 252. I'm going to add these together and get 301. And so that's the value of our discriminant. So b squared minus 4ac is 301. That is definitely not a perfect square. We're going to have two irrational answers. And now we're going to write everything in. We have b, which is 7, so we're going to say -b, so we'll write -7 plus or minus the square root of 301 all over 2 times my a value, which is -7. All right, switch it up. I'll put -14 right there. Now these negatives will cancel out. You could also put 7 plus or minus the square root of 301 all over a positive 14, because those negatives would cancel out, but either one of these will be the right answer. Now 301, you're like, how could we break that down? Well, let's take a look at something real quick. Let's just go ahead and do 301 divided by x, and look at a table here, and just start typing in numbers, right? 3, 4, 5, 6, 7. 7 works. Alright, but guess what? 7 times 43, 43 is a prime number, so you know what? Since 43 is a prime number and it's only 7 times 43, there's nothing we can pull out of that square root of 301. So we're going to have to leave it as this or this. We're going to search for two answers, this one or this one. They're both the same thing. Ooh, looks like I found it. Answer choice A. Right there. Alright, let's go into our last problem that we're going to do using the quadratic formula. So, first thing you got to do is you got to set everything equal to 0. To do that, all I'm going to do is I'm going to add 8 right here, and I'm going to add 8 right there. So we're going to be left with negative 6x squared. We've got a minus 3x, so I'll put minus 3x, and then we have negative 2 plus 8, which is a 6. We're going to set it all equal to 0. Now here it looks like I have more negatives than positives, so here's what you could do to make it a little bit easier. I'm just going to multiply everything by a negative and make it 6x squared plus 3x minus 6 equals 0, which makes my a value, b value, and c value a little bit easier. Easier meaning if there's two positives and one negative. Ooh, found another thing. Everything here is divisible by 3, so I'm just going to divide everything by 3. Now, by doing that, it just makes me be able to use smaller numbers when I'm doing the quadratic formula. Do you have to do that? No, you don't have to. It does make it easier. Now I'm left with 2x squared plus x minus 2 equals 0. Why didn't I do this before? Because all the other problems, you didn't have common factors that everything was easily divisible by. So now I have my a value. I'm going to say my a value is 2, my b value is 1, and my c value is negative 2. Now what if you didn't simplify this and make it a little bit easier? You could still do it, alright? You could still say your a value was negative 6. You could still say your b value was negative 3 and your c value as a positive 6. So I'm going to do it side by side. I want you to see that it doesn't matter. Either way, you're going to still be able to get the final answer. Alright, so step number 1, find our discriminant, which is b squared minus 4ac. And over here, I'll find the discriminant over here as well, which is b squared minus 4ac. So right here, I'm going to go parentheses squared minus 4 open parentheses. My b value is 1, my a value is 2, and my c value is negative 2. So I get 1 plus 16, and I get 17, so I know my discriminant is 17. Over here, if I do the exact same thing, which is b squared minus 4ac, put negative 3 right there for my b value. My a value is negative 6, and my c value is 6. I get 9. A negative times negative is a positive, and you get 144, but you add those together, and you get 153. Now, would you agree 153 is a little bit larger than 17, so it does impact our final way of solving it. This is a little bit easier. All right. So right here, I'm going to take the first one, and I'm going to say, here's our quadratic formula: negative b plus or minus the square root b squared minus 4ac all over 2a, and I'm going to take my numbers right here. Negative b is negative 1, so I'm going to put negative 1 plus or minus the square root of 17 all over 2 times my a value, which is 4. And I can clearly see which answer I'm going to choose. I'm going to be choosing answer choice D. Over here, if I do the exact same thing, it's a little bit harder. Like negative b, that's going to be positive 3, plus or minus the square root of 153 all over 2 times my a value, which is negative 12, you can kind of see that you don't see that answer anywhere. So here's the problem. You have to know that 153 can break down into 3 times 51, and 51 breaks down to 3 times 17. You have a pair of 3's, so that simplifies to 3 radical 17, and you're probably freaking out right now. You're like, how am I supposed to know that? You have to know how to break down radicals, so it's always better, if you can, is divide everything by a common factor to make your numbers smaller. Now, this would still work, because if I do 3 plus or minus 3 radical 17 all over negative 12, what number goes into a 3 and a negative 12? Well, that number is 3. I could put a 1 and a 1 and a 4, and what do you get? You get the final answer, 1 plus or minus radical 17 over negative 4, which you can clearly see that's the answer that they have listed. Okay? This blue answer and this red answer, they actually mean the same thing. This happens to be the negatives in the denominator, this one the negatives in the numerator, but they mean the same thing. So, quick review. What we're going to do, one thing you need to know, is you definitely need to know the quadratic formula, which is right here. Alright? Your x value, where it crosses the x-axis, will always equal this formula. Next thing, you need to be able to get everything equal to 0. Alright? It has to be in standard form. What is standard form? A x squared plus bx plus c equals 0. It has to be in standard form. Then you have to identify a, b, and c. You have to find the value of your discriminant. Remember, these numbers were known as our discriminant. And when you plug all of your numbers in, this one we didn't have to simplify the radical. This one we did have to simplify the radical to be able to get your final answer, which was answer choice D. Alright, so we will be having a Zoom class. If you need it, just let me know, and I will help you. You'll have a good day.